particle moves along the curve y equals 2 sine pi x over 2. As the particle passes through the point 1/3 1, its x-coordinate increases at a rate of square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at this instant? Okay, so first, it'd be best to write it down. So y equals 2 sine pi. Okay. Through 1. Okay. So, at first, I mean, looking at it, it's hard to tell. So, like, what you're supposed to do next. So I think so. The best thing to do would be to draw it. So, graph. You know it's sine, so. No, so, and it's asking for the distance from the particle to the origin changing at this instant. So the distance from the particle from the origin would be this. This would be right here. And this would be c. This would be x. This would be y. And y would just be 2 sine pi x over 2. So, but for that y, we can substitute a 1 because the 1 right here. So, this would be 1. This would be 1 over 3. And now we can use Pythagorean theorem to get this side, which is equal to 10 over 3. Okay. Now you have c, which is what we need. And since we use Pythagorean theorem here, we can use it here. Okay. Now, the first step, you have to differentiate it. D over distance over time. I mean, not distance over time. D with respect to derivative of t. So this would be 2c. C. That should not be that. Two x. Derivative of d of x with respect to t plus 2y and derivative of y with respect to t. Okay, we now have this. There's 2's in common, so we can just take 2 out. So that, and then we're looking for this right here. So let's make this by itself. So x d of x d of t plus y d of y dt all over c. Alright, so next we can input the stuff we know. So derivative of c t. So we know x, which is just 1/3. We know d of x, which is, oh yes, the x coordinate increase at a rate of square root of 10 centimeters per second. That's also one of your givens. So this would be right here. Yeah, these are one of your givens. And this is what we're looking for right here. Okay. So, next is d of x, derivative of x with respect to t, so which is just square root of 10 plus y, which is 1, times d of y. Now, where's d of y, derivative of y with respect to t? Well, this is just right here. You find the derivative of that. So to find the derivative of that, we can bring this to the side. So this would be 2 sine y equals 2 sine pi x over 2. Derivative of this would be 2. This 2 stays for the ride. So 2 derivative of sine cosine. And this is chain rule, so you have to the inside function, then the outside. The outside function, then the inside function. And this, the derivative of this would just be pi over 2 times d of x over d of t, d of x, derivative of x respect to t. And because it's a function of time, and then y prime equals, the 2 cancels out with pi, then you're left with pi cosine pi x over 2 and times square root of 10, because that's the derivative of x is. Next, you can plug in x right here. So then you get 1/3 over here, so you multiply this out and to get pi over 6 times square root of 10. All right. Now, cosine pi over 6 is square root of 3 over 2. This goes away. You're left with square root of 10. So this would just, the derivative would just end up equaling square root of 10 times pi times 3 divided by 2. Okay, now we have that. Now we can plug this back into the equation right here. So let me erase this. So that's enough room. Okay. So x d of c over d of t 1/3 times d of x over d of x. The derivative of x with respect to t. D of x will just derivative of x will just be square root of 10. Plus y, which is 1. This would just be pi square root of 10 square root of 3 over 2 all over c, which is what we got right here as square root of 10 over 3. Now, all that's left is to simplify. So you have this is equal to 3 square root of 10 over 3. This is the same, this cancels out. It's pi square root of 10 square root of 3 over 2. 10 cancels out here. Then you're left with 1 plus pi square root of 3 over 2 over 1/3, which is also equal to, we'll simplify it to, this would flip. Yeah, this would flip because pi square root of 3, 2. If you're dividing, 3 goes on top, so that you're left with 3 pi square root of 3 over 2 plus 1. And the unit of time would stay the same. So this would be centimeters per second. So this right here is your answer. Now, but we're not done. No, homie. We're not done. So what's left is the statement. Now, we were looking for how fast the distance from the particle to the origin was changing at this instant. Well, all we have to write is the distance from the particle to the origin. Is increasing at a rate. Always have to mention rate because that's what we were looking for. Rate of 1 plus 3 pi square root of 3 over 2 centimeters per second. Boom. Alright, so that's how you do number 29 to find how fast the distance is from the particle to the origin changing at this rate. So this whole time we had c, which is the distance, but we didn't have the rate, which is what we found right here.